In this lesson, we're going to learn about the functional groups ketones and aldehydes. So ketones are functional groups that have a carbonyl group, which is this group here, a carbon that is double bonded to an oxygen, and the carbon is then bonded to two other carbons, so on either side. So that carbon, because it already has two bonds to the oxygen and then one to each of the carbons on either side, it already has 4 bonds total. So this carbon is not going to have any hydrogens attached to it. So carbon and then whatever else is attached to that carbon. So in terms of naming and drawing ketones, we're going to identify the root, so whatever the longest chain is that has the carbonyl group in there. Then the suffix, so we're going to use that to give us the position of the ketone, so what carbon that is off of, and we're going to change the ending. We're going to chop off the E and add ONE. So for example, if on a 4 carbon chain, so butane, we're going to change that to butanone. So we're going to get rid of the E from the butane and replace it with ONE. And then we are going to have the prefix, the name and number of any other alkyl or halo side groups that we have. So example here, I have 1, 2, 3, 4 carbons as the main chain. In terms of numbering, for the carbonyl group, the lower numbering is if I start from the left, so carbon 1, 2, 3, 4, and that gives the carbonyl group off of the second carbon. So the one is off the second carbon. If I were to move from the other direction, I would have carbon 1, 2, 3, 4. So that would make it off the third carbon, and that's not the lowest numbering. So but for 4 carbons, so butane, and then we have the ketone off the second carbon. So this is going to be called butane, and normally we would give a position of 2, but in this case, we don't need to give the position because there's actually only one way we can draw this. So the carbon double bonded to the oxygen cannot be off the first or last carbon, because then it wouldn't be a ketone. Remember, ketone has to be bonded to 2 other carbons. So it can't be off of an end carbon. And then in terms of between 2 and 3, if that double bond O was off of this carbon, then we actually would have changed our numbering and said 1, 2, 3, 4, in which case it would still be off the second carbon. So in this case, there is only one position where that oxygen can end up going, and if there's only one place that it can go, then we don't need to use a number to give its position. So butanone, there is only one place that that double bond O or the ketone can end up being located. Okay, so aldehydes are also a carbonyl group, so a double bond O, but they are going to be on a carbon that is at the end of a chain. So this time the carbon is only attached to one other carbon, which means it only has 3 bonds between the other carbon and the bonds to the oxygen, and so it's also going to have a hydrogen. So ketones and aldehydes are the same functional group. They're both carbonyl groups. Ketones are double bonded to an oxygen somewhere within the chain, and aldehydes are the double bond to an oxygen on an end chain carbon, and then a hydrogen is also going to be attached to that carbon. So in terms of naming and drawing aldehydes, we are going to once again find the longest chain that includes the carbonyl group, so that's going to be our root. We are going to change the ending to Al at the end, so we're going to drop off the E and end in Al. And then we are going to give any alkyl side groups or halo side groups for the prefix. And we're going to give their position, so we're going to name and number those. In terms of giving a position for the aldehyde. We don't have to do that because it's on an end carbon. We are always going to say that that is carbon number 1. So we always do our functional groups so they have the lowest numbering. If this can only end up on an ending carbon, we are just going to say that that is always carbon number 1. So we don't need a position for aldehydes. So in this example here, my longest chain is 5 carbons. So that is pent. Once again, lowest numbering for the functional group, which is over here. There's my carbonyl group. So this is going to be carbon 1 from this end, moving that way. And so off the 3rd and the 4th carbons, there are methyl groups. So I have 2 methyl groups total, so dimethyl off the 3rd and 4th carbons. And once again, I don't need to give a position for the carbonyl group, the aldehyde at the end, because that is assumed to be on carbon 1. So this is 3,4-dimethyl pentanal.